Welcome everyone. This is the 7th episode of our sensors and their microcontroller interfacing video series. We are following a project-based approach in the series. If you want to understand the complete workflow, you can watch the whole playlist by clicking the playlist link in the video description below. In this video, we will interface the analog signal conditioning circuit we built till now to the Arduino Uno microcontroller, and we will also display the environmental temperature detected by the negative temperature coefficient thermistor using 16:2 LCD display. This simulation is carried out by using PROTEUS 8 simulation software. In the 6th part of the series, we have done simulation of the complete signal conditioning circuit. Let us now open it and complete our today's task. Okay, this was our signal conditioning circuit for NTC thermistor. Now let's bring the required components, complete this video series. The Arduino Uno R3 and the LCD 16:2 alphanumeric display. To do so, click here and write Arduino, and here double click Arduino Uno R3. But first, make sure that your Arduino library is included to your PROTEUS. Similarly, include your LCD right here, and then select this one, LM016L 16:2 alphanumeric LCD. Press OK. Now we brought the required components here. The next task is interfacing or connecting this signal conditioning circuit to the Arduino and also to the LCD display. As a brief introduction, Arduino Uno R3 has the following pin description. If you need the full pin description of Arduino Uno R3, you can go to the official website of Arduino CC and read everything there. You can get the datasheet here. You can get the pin description here. Everything you need is available here. I will put the link in the video description below. Arduino Uno R3 has the following main features. It has those 14 digital pins. They can be used as either input or output, and also those analog pins. Arduino has a built-in ADC that can convert the analog input from those 6 pins. If you run out of digital pins, those analog pins can also be used as a digital pin. Arduino Uno R3 is based on the Atmega 328P microcontroller. So when we come to our main task, connect the signal conditioning output from the NTC signal conditioner we designed before to one of those 6 analog pins. Okay, let's adjust our signal conditioning circuit, drag it to above, and now let us put our Arduino Uno microcontroller to the workspace, rotate it clockwise, and put it here. Here it is. Those are the 6 analog pins to which we can connect our 0 to 5 volt analog signal from our signal conditioning circuit. Let's connect the output from this circuit, this voltage, to any one of them. But for my case, I'm connecting it to A0. So the analog voltage is connected to anode. To reduce the wiring mess in your simulation, you can also use the go to and from terminals. For example, go to here and remove this wiring and rotate it like this and put it here. Your go to terminal is here now, and place your from terminal here, rotate it like this and put it here. Then give the same label name for each of them. This is the go to terminal, and right click it and give a label name T1, and write the same label name to the from terminal. Right click and give a name T1. Press OK. Now the wiring is completed this way. We can remove the tedious wiring in our simulation. Let's do the same for our LCD 16:2 alphanumeric display. The 16:2 LCD displays texts within a row of 2 and 16 columns. It has 16 pins with VSS is a ground, VCC or VDD is a source voltage of 5 volt. VEE is used to adjust the contrast of the LCD. RS as a register select, read or write pin, and the enable pin. The D0 up to D7 are the data pins, and the 15th and 16th pins are used for the backlight LEDs or the LCD. There are two modes of connection for a 16:2 LCD display. We can either use the 8 data line mode or the 4 data line mode. In the 4 data line mode, the 4 data lines are connected to the microcontroller. In the 8 mode, all the D0 to D7 data pins are connected to the microcontroller. Here in this video series, I'm going to show you only the 4 mode connection. Place our LCD to the workspace, put it like this. Now connect VSS to the ground and connect VDD to the 5 volt power source. Okay, connect the right read pin to the ground too. Now in the 4 mode connection, connect RS register select to any of the digital pins of the microcontroller. Here I connected to the 12th pin and the enable pin to the 11th pin of. Connect the 4 data pins of the LCD to the 4 digital input-output pin of the microcontroller. Here, let's start from D4 to the pin 5 of the microcontroller and do the same for the rest of the LCD pins. Okay. We finished connecting the LCD to the Arduino microcontroller. This is the hardware part of the simulation. Next, we will set up our Arduino IDE in accordance with our schematic. Arduino needs to be programmed to perform the required task. To program our microcontroller, open the Arduino programming IDE. This is the interface of the IDE, the integrated development environment. You can download the software from the official website, link I put in the video description below. All Arduino programs have the following structure. The first one is a preamble. You can initialize your variables. You can include the libraries here. The next one is the setup part. You can set up all the inputs and outputs of your schematic here. And the third part is the main program part. This part contains the main program of your task. So let's program our Arduino microcontroller to display the environmental temperature on our LCD. Here in Arduino IDE, you can create a new program by just clicking the file menu and clicking new sketch. But also Arduino IDE has a lot of examples already made for various illustrative tasks. To find the one that resembles to our task, just go to file and go to examples. Then you can browse any of those examples there. For example, the 01 basics, the analog read serial for bare minimum, for blink, LED blinking, for various tasks. For example, for LCD display, just go to liquid crystal and then click one of them and edit the code according to our design. So here in the new Arduino program I just created, let's include the liquid crystal library here in the preamble. Go to sketch and then go to include library, then click here liquid crystal. It automatically includes the liquid crystal.h library, which enables us to work with a LCD display. Next, let's declare the variables for defining the connection between the Arduino pins and the LCD pins. Just write const int rs equals 12, e equals 11, d4 equals 5, d5 equals 4, d6 equals 3, d7 equals 2, and semicolon at the end. Then pass those variables to liquid crystal LCD rs E, D4, D5, D6, D7, then semicolon at the end. Then declare the variable defining the analog pin from our signal conditioning circuit, const int T pin equals 0 or A0, semicolon. Now we define all the required variables. Next, let's set up our 16:2 LCD display within the void setup function. Here, set up your LCD by just writing LCD.begin, semicolon at the end. Inside the parentheses, just write 16:2 to define it is a 16:2 LCD display. Next, we'll write our main task, that is reading the sensor value from the signal conditioning circuit and displaying it to the LCD. This is our main task. Just we will write it in the void loop function. To do so, read the analog value from the anode analog pin of the microcontroller by just writing V voltage, or just say it V naught equals analog read in T pin, semicolon. V naught needs to be declared as an integer value, int V naught. Program our microcontroller to write what has been read to the LCD. Don't forget to save your code to an appropriate folder. Arduino Uno R3 has a 10-bit built-in ADC. It converts analog voltage from any of the 6 channels to the power of 10 quantization levels, or 1024 quantization levels. It is a designer's job to bring the analog voltage in a range of 0 to 5 volts. That's what I'm doing until this video series. Our Arduino microcontroller gives a quantization value of 0 for a voltage of 0 volt and 1 for a voltage of 0.004886. At the end it gives 1023 for a voltage of 5 volt. Here, for a quantization level, is calculated based on a linear relationship between L naught with a formula 1023 over 5 times B naught rounded to an integer. Therefore, this analog read function reads the quantized value L naught, but we need to extract the analog voltage V naught from the signal conditioning circuit using the formula V naught equals 5 over 1023 times L naught, which equals 0.008876 times L naught. To perform this calculation using our Arduino, V naught equals 0.007, the quantized value, summing it as a floating point value by writing float V naught. In the previous video, we have developed the linear relationship between the environmental temperature in degrees centigrade with the voltage from the signal conditioning circuit V naught by a formula T equals 50 minus 11 times V naught. So we need to perform this calculation using our Arduino microcontroller by writing the code T dig C, let's say it, equals 50 minus 11 times V naught. Define T dig C as a floating point value too. Okay, still now we have been doing temperature, having the voltage information from the signal circuit, but finally we need to display this temperature value in degrees centigrade by using our LCD. There are a lot of LCD functions we can use. To understand each function, you can read the details from the Arduino.cc official website. For now, we are going to use some of them. As mentioned before, LCD displays texts within in which each row contains cells. That is, there are 32 cells in total. The characters, punctuations, or custom characters can be written on each. Let's print some text on our LCD. Let's give our task a name. by calling the LCD functions by d.print inside parentheses and in double quotations Orion tech tube. By default, write the print function texts starting from the first cell. The index value is 0, 0. Each cell of the LCD can be considered as an array element and indexed by columns and respectively. For example, the first cell is indexed by 0, 0. So by default, our print function displays texts starting from this cell. To begin our text in a different location, we can set it by writing a code lcd.setCursor. For example, here I want to begin the text cell 0, 0. Writing this is worthless. Now let's check if our code till now is correct or not by just clicking sketch and then verify compile. Okay, here is a mistake and sketch it again or compile. Okay, we missed a semicolon again, verify and compile. Uses Arduino is a C. It uses all features of C. So the syntax is almost a programming language. Now our program runs without error. Let's generate the binary file for this program, that is the ones and zeros. I'm going to upload the binary file to our Arduino controller. Generate it by going to sketch and then export. Click export compiled by. Okay, we generated our binary file. Then go to our PROTEUS. Double click in the program file. Browse our binary file by clicking this. Just the folder. Go to a folder where your binary file is. Select this one, the hex file, and then click open here. Then press OK. Now we uploaded our binary file to the Arduino microcontroller. After uploading the binary file, let's try running our schematic. Okay, let's make this positive. Okay, run it again. As you can see, it successfully displays Orion tech tube on our LCD, and this starts from the first cell. Each character, for example, O is written in one cell and the space also takes one cell. Every punctuations are written in a single cell on the LCD. Next, let's display the measured temperature on the second row of the LCD. Go to our program again. Inside the void loop section, here to text the first of the second row, that is the first, and in the second indexed by 0 to temp, shortly for temperature. Let's count the characters. These 10 characters, including the space between room and temp. So we need in the second row of the LCD to write this text. Next to this text, we need to display the temperature value. So it should start at least in the 11 cell. So let's leave a space, one space, so one cell, and start writing the value at the 12th cell. This cell can be indexed by 1. Now print our temperature value using LCD TDC. Okay, compiling this. Next, generate the binary file. Export binary inside the sketch menu. Also done. Now upload our binary file again and selecting the hex file in our build folder. Run our PROTEUS again. As you can see, it displays the temperature successfully. As you can see, the environmental temperature from the negative temperature coefficient thermistor is 50 and the displayed temperature value is 49.89. This variation comes from non-linear nature of the thermistor. If our sensor was approximately linear like LM certified temperature sensor, this error would not occur. Let's make our display fully informatic by adding a unit. Like for example, this temperature is in degree centigrade, so we need to display degree centigrade next to this value. So we need a special character for degree, and let's create it and make our program more clear. Let's round this temperature value to the nearest integer by writing here round, and let's shorten this text to rtemp to save some cells of our LCD and start the value at 8.1. Let's generate the binary file again by clicking export compiled binary and upload it again to our Arduino. Okay, now let's add a unit degree centigrade to the right of this numeric value. Before that, let's see how to generate custom characters like degree or ohm or some other special characters. Each cell in LCD is represented by 8 by 5 pixels. To generate a custom character, we need to turn on or off each pixel. For example, to write a degree symbol, let's turn on those pixels and turn off this one, and turn off all the rest. Okay, now this array of bytes define our custom character degree. So let's copy this one to the preamble part of our code here and give it a name dig, shorthand form of degree. And in the setup section, let's create this character by writing lcd.create_char of 0, dig, semicolon. Now go to the main part of the code and here set our cursor to an appropriate place at 12.1. Here write lcd.write byte 0, the creator character. Then we put our degree symbol at the 12.1 cell of the LCD. Then we need to write the C next to this degree symbol. To do so, just set our cursor at the 13.1 cell of the LCD and write lcd.print C here. Let's compile our code, then export the compiled binary, upload our code, then run the simulation. Okay. Now our simulation also runs successfully. As you can see here, the 5 degree centigrade environmental temperature detected by our sensor is displayed here in our LCD as a 5 degree centigrade. Let's reduce this. 4 degrees centigrade detected by the sensor is also displayed in the LCD, decrementing or incrementing the sensor temperature within the range of -5 to 50 degrees centigrade. Then see the displayed value. Overlapping of texts on the LCD 12.00. The 0 and the degree symbol are overlapped. We can solve this overlap by adjusting those indexes. For example, let's put our degree symbol, make this index to 13 and this one to 14. Then export the compiled binary, upload it to the microcontroller, then run it again. Now there is no overlap. So as you can see here, the displayed temperature value is 12 degrees centigrade, but the detected temperature is 11 degrees centigrade. This difference comes from the nonlinear nature of the sensor. If we can use a linear sensor, the detected temperature by the sensor will exactly be displayed on the LCD. So this is a problem of nonlinear sensors. There will be some mismatch in the displayed value and the detected value. Okay guys, this was all about this video series. Useful links in the description below. Just click on them and see the information if it is relevant for you. In the next video series, we will be designing a temperature controller by adding air conditioner. So we will turn on or off the air conditioner based on the reference temperature set by you, the designer.
Okay, thanks for watching. Don't forget to like this video and subscribe the channel. Feel free to leave your comment.